Good morning, class. Let's get down to our last um, day of the osmosis lab and see what happened. So, kind of recap and go over everything. Is day one, we put the gummy bears, we masked them on a trip. I didn't use a tryptine balance. I used this balance. Ooh, make sure I don't knock too many things over. It's just an automatic balance. It looks like that, so it's nice and quick for me. And we masked them, and then we measured them in centimeters using a ruler. And we measured the length, width, and height. And that's going to give us our volume. Now, the mass is going to give us, of course, the mass of it. And if you remember, we went from about 2 grams, and we jumped up, and it got really large, right? So which one got larger? If you remember, the one in distilled did. And we will talk about that today. And why the distilled water ended up getting larger than the tap water. A lot of people always think tap, but it will be distilled because you have 100%. And we'll go through what this all looks like in a little bit. Now, we come back to yesterday, and when I made the measurements, and now we make our measurements, then we put them in salt water. So basically what I want you to think about is, what does salt do? What is the main thing here that the salt water is going to do? One thing you have to think of, and I always tell people this, sorry, I just want to get that one thing of light out of there, is salt does not suck anything up. It does not dry stuff out. It does not, suck it up like a vacuum. It doesn't do that. All it does is it changes the concentration of water. And since it changes the concentration of water, now the water is going to move a different way. So day 3 after soaking, you can see they look a little different. If you look at this one is smaller and it's floating, which, why float? Well, same reason you float when you go into the ocean, because the concentration changes the density, and therefore you're more buoyant, or you float more. And here's the green one. Now, if I'm looking at this, they ended up getting smaller. Now, why would that happen? That happens because when I have my gummy bear, now let's say this gummy bear was soaking a day in distilled water, it'd be all big. And when I drop it in there, and I put salt water in the beaker or in the cup, what happens? Well, my highest concentration of water is in the gummy bear. Where do I have my lowest concentration of water? Actually in the salt water. So therefore, water will move from an area of high concentration to low. So it moves out of the gummy bear. That is called osmosis. Okay? Same thing, the reason that went into the gummy bear. When we first did this, we put water in here and then we put a gummy bear in. Where do I have the highest concentration of water at the time? Would be in the cup. Where's my lowest concentration? In the gummy bear. Therefore, it goes through. Okay? So let's make these measurements. These will be our final measurements for this. And then you can record this and I can explain what you're going to do next. There's that one. I think the gummy bear would last another day. The salt water, too much soaking for the old gummy bear. I'm recording. Okay, and now there's the final one, and I'm going to make those measurements here. Okay, I'm going to make those measurements right now. So if you remember on your sheet which ones were which, if I remember correctly, the red one was in tap and green was in distilled. And by looking at them, green looks still to be a little larger. I'm going to minimize my window here, and let's pull up the gummy bear. All right, this is where we left off yesterday, so we can continue on with that today. All I have to do is figure out, give me 1 second while I turn on the balance. Okay, let me zero it. and then we can make some measurements. All right. All right. So the green one is, I'm going to go down here because I'm doing this here. Okay. So the green one is 10.25 grams, and the red one oops, I messed that up. I gotta zero this again, sorry. Come on. All right, and the red one is 8, there it goes, 8.58. Okay, and looking at that, you can see the final after salt water. So it did lose mass. It did lose, of course, it did lose water left it. And it looks like the green one lost more, which does actually make sense when we talk about it. So measurements, these are going to be kind of hard. My one gummy bear is pretty beat up. I'll try my best to kind of get a rough estimate because it's not going to be perfect. Looks like to be about 3.6. Okay, the width of the gummy bear. Oh. 2. And then the height is about, and these are really rough estimates because the gummy bear is so congealed now is the best way to describe it. He's not in tip-top form anymore. All right, 1.4. Okay, let's go over to the red one. Make that measurement. Okay, looks like we are at 3.8. Oh, wait. I might have measured that wrong. Oh, yeah, hold on here. 3.4 centimeters. And the width of it, it's to be about 1.5 centimeters. And the height, about 1.2 centimeters. Okay, let me grab my calculator here, my phone, and we can look at this really quick. Come on. Oh, maybe I should get to the calculator. Mr. Teskey. 3.4 times 1.2 is 6.12 centimeters cubed. And over here we have 3.6 times 1.2 times 1.4 and 6.048. Now you can see centimeters cubed. You can see they're going to be really, really close to size. It looked like the green one is a little larger, but you know, when you measure length times width times height and what it's coming down from, they're going to be very similar. Now you can definitely see there's a 2-gram difference here of the mass. All right. Now that concludes our gummy bear lab for all of the different data. Now we'll talk about how to do this, okay? And the best way to do this is you have to understand when I look at this, this is your initial, this is the start, here's the final. That's from day 1 to 2. Day 2 to 3, this becomes the initial, this becomes the final. And what we're going to do is we're going to figure out the percent change in water of the gummy bear. And I'm going to have a separate video for that because I think it'll take a little longer. Okay? All right.